Okay, so let's just begin. Um, Hello, this is our MEC 3380 final project, optimization of a shower rod by Alek, Ibrahim, and JP. So for the introduction, like the purpose of a shower rod is to hold a towel in a bathroom for easy access to the towel. Usually these bars, these rods are subjected to differing temperatures, humidity, loads from a dry towel or even a wet towel. And the customer need here is just a towel rod that withstands the stresses from continual hanging and removal of towels. So here's the CAD mod that we came up with. Um, Pretty much just a basic towel rod, and it's made out of aluminum. Here are material properties. The material is 6061 aluminum with a Young's modulus of 68.9 GPa, Poisson ratio of 0.33, and yield strength of 276 MPa. So as for our set loads and boundary conditions, it's an encaster boundary condition that was placed on each rod holder. 0.833 pressure, which is a 5-point force, was placed on the top surface of the rod.
So for the design optimization, we decided we want to optimize the design by trying to decrease the volume of the design and while still being able to resist the typical deflection a towel would give. And for our objective function, this is it right here. The F equals 2.356, yada, yada, yada. X1 is the rod diameter, X2 is the load in PSI, that top load, and then X3 is the rod length. And then our constraints is obviously the deflection, and that would be C1. That C1 equals 5.145 e to the negative 4, so that it makes sure that it doesn't go too thin and doesn't meet the deflection requirements. So for the design variables, we originally had ours at a 0.5 diameter with a 0.833 pressure on it, and then a length of the rod is 12 inches. And so our three variables we use is the diameter, the load, and the rod length.
All right, I'll be going over the design benefits. So economically, with our improved design, we would be able to sell, or the company would be able to sell the product cheaper, which would make it more economical for users. It'd also be more sustainable for the customers that purchased it. And yeah, once again, it would be cheaper to manufacture for the companies themselves. So here's a picture of the analysis we ran on the CAD model. It is a static simulation with the 5-pound force acting on the center of the rod, and demonstrating the pictures the deflection as a result of the load. And then here are the values. These are the variables for the Taylor series approximation equation we have below. X1 is the diameter of the rod, X2 is the length of the rod, X3 is the pressure of the rod. And here's the equation. For the optimized results, we came up with these values here. The diameter would equal 0.4836 inches, pressure equal to 0.833 psi, and the length of the rod itself would be 12 inches. And in conclusion, our optimized design for the shower rod is cheaper to produce, is more sustainable, and is cheaper to buy for the end for the user than what we started with, and without significant reduction in the load bearing requirements of the product. So therefore, it is an all around ideal improvement to the design of the product, and that is all.